Module 1, Lesson 14, Reflections. Again, we are starting with some major concepts from previous lessons. Reflections are distance preserving. That means our segments are mapped onto segments of equal length, which means they are going to be congruent. It is also angle preserving, which means we are going to map angles onto angles of equal measure, so angles are congruent. And the size and shape of our figure stay the same when you flip the figure across the line, but this time our orientation reverses. Remember, this is looking in the mirror. So when you see your right eye, it looks like your mirror view's left eye. Reflections can be performed across any line in the plane. The line of reflection between a figure and its image is the perpendicular bisector, we know those words, of the segments connecting corresponding points. So let's look at our diagram right here. And here's our line of reflection. And the segment connecting corresponding points, so B and its image B prime, this segment right here, our line of reflection is going to be the perpendicular bisector of that segment, because any point on the perpendicular bisector, so this point right here, is equidistant from the endpoints of that segment. Nifty stuff. Our vocabulary: a reflection across line R, which is our line of reflection that we just talked about, has the following properties. A point A that is on line R, the image of that point is itself. So point A here does not move. This is like our center of rotation. So if you're on the line of reflection, you flip over and become the image A prime, but you do not change position. The notation for this, the small r denotes reflection. The subscript tells us our line of reflection, and in parentheses is our point or our figure, and that equals our image point. So very much like the notation for rotations, just a little different. So this reads, the reflection of point A across line L is point A prime. So now any point that, like B, that is not on line R, then line R, our line of reflection here, is the perpendicular bisector of our segment, B, B prime. And we saw that. So again, our notation, the reflection of B across line L is B prime. Now again, a reflection is an isometry, so corresponding parts, segments and angles are congruent. Distance preserving, angle preserving. Some constructions that we are going to need to be able to do here. Let's read our notation. The reflection of triangle ABC across line N. So how are we going to reflect our figure? You guessed it, we are going to construct a perpendicular line from point A to the line of reflection. So do you remember how we construct a perpendicular line from a point not on the line? You may want to get out your construction instructions. The first thing we do is we draw a circle that intersects our line, and then we use those points to create a perpendicular bisector. So here is our perpendicular bisector of our created segment. That makes this perpendicular to our line of reflection. Then we measure the length from A to the intersection point. We just use our compass to measure this length right here. And we know that our line of reflection is the perpendicular bisector of the segment between our points. So we measure this length, and then we just measure on to A prime. So these two segments will be congruent. And then we simply repeat the process for each vertex, and we end up with A prime, B prime, C prime, and we have our image. We have reflected triangle ABC across line N and created our image triangle A prime, B prime, C prime. Remember, order matters on these. Our next construction is to find the line of reflection. This one's a little bit easier. A few less steps. Not necessarily easier, just a few less steps. So we know that our image and pre-image points are equidistant from the line of reflection. We know that our line of reflection is the perpendicular bisector of the segment that connects these 2 points. So if we draw the segment that connects our image and pre-image points, and then construct the perpendicular bisector, that becomes our line of reflection. Our perpendicular bisector is our line of reflection. Now, the important thing here, all other points and their corresponding images will be reflected across this line. So we can connect all of our image and pre-image points and know that they are perpendicular to the line of reflection and equidistant. So these segments are congruent, these segments are congruent, and these segments are congruent, and all of them are perpendicular to the line of reflection. So only one step on this. That's kind of nifty. These are some fun constructions that we are going to be doing with reflections.